Here on normal forms, we have Boyce-Codd normal form. So third normal form allows a non-key attribute to determine a column if that column is only part of the primary key, prime attribute. BCNF closes this loophole by saying, okay, there's a non-key attribute cannot determine anything at all. So a non-key attribute can do nothing here. But third normal form only says that a non-key attribute must determine can determine a key attribute. It should not depend on other non-key attributes. But he says that it can determine nothing at all. So for example, we have a composite key like this, and we have a non-key attribute professor. Professor determines the subject here. If we put the professor here, then that's not okay for Boyce-Codd normal form. But the third normal form allows it because a non-key is depending on key. The third normal form only strictly forbids a non-key column from pointing to a non-key pointing to another non-key where both are regular attributes. Because subject is part of the primary key, third normal form looks at these tables and considers it valid and walks away. But the Boyce-Codd normal form is stricter. It doesn't care if the destination column is part of the key or not key. It looks only at starting point professor because professor is not a candidate key on its own. BCNF flags it as a violation and forces the table to split. So to understand this, what we can also see is that Boyce-Codd normal form is stricter. It does not care if the destination column is part of the key or not. So before we have this table, we have composite key like this, and this was composite key where one is foreign key, one is primary key, but both are used as a composite key, primary key of this table. Then we have no attributes that depend on each other, no dependency. Then we have other table that we have one key and one key attribute, we have dependency, where this is derived. This satisfies Boyce-Codd normal form. In table 1, there is no individual in table 2, dependency is this, because professor is now official primary key of that table. So this is one key can go to one attribute, this is fine, but it's not that we cannot put an attribute here because that attribute goes to this and that goes to this is not fine. Only one attribute goes to only one key, that's it, at max. So the starting point must be a candidate key is perfectly satisfied. So BCNF is no non-key. For example, something that is not a key can go to a partial key. It must be that a key determines a non-key attribute and two keys should be left alone in a table. So if there are two keys, they should be left alone in a table, and it must be that a key determines a non-key. So a key determines a non-key attribute. So only a key can determine a non-key attribute. So a non-key attribute is strictly forbidden for determining a partial key if a dependency exists. The starting point must be a candidate key. To make sure that you have matching set, we have before fourth normal form, the composite, we have this structure. But because we know that there is no sense to have all of these in the same table, we have employee ID, we have project and hobbies. So employee ID goes to project and employee ID goes to hobby. That makes no sense because Boyce-Codd normal form only looks at functional dependencies. A goes to B. It completely ignores the hidden multi-valued cross mess. So based on that, there is no non-key attribute here, so Boyce-Codd normal form is satisfied. But after the fourth normal form, the composite key, we keep both of these composite in one because they belong together. They make sense, employee and project. And then we make a new table for employee ID and hobbies. This is fourth normal form. Just clean. Nothing that's weird. Then we have Boyce-Codd normal form stops a regular attribute from messing with the primary key. So a normal attribute cannot mess with the primary key, where fourth normal form stops completely unrelated lists from being showed into the same room. In fourth normal, if something is not related or doesn't belong in the room, we put it in a separate room just based on the common sense. Another thing is that, let's clear it up, one thing that determines another, which indirectly determines a third thing. For example, hobby in our example determined project and project determined employee ID is actually a transitive dependency, which is what third normal form handles. In fourth normal one, the situation is different. Project and hobbies have absolutely no relation to each other. A hobby does not determine a project and a project does not determine a hobby. So a project doesn't tell anything about the hobby and the hobby doesn't tell anything about the project, right? They are completely independent lists, happen to bring to the same employee ID. The corrected rule is that it isn't strictly about keeping two keys at max per table, but you can store two or more independence values in the same table. So, but things that should belong together. While BCNF stops a regular attribute from messing with the primary key, fourth normal form completely removes that unrelated thing. We can go a little bit deeper in Boyce-Codd normal form. That looking at the Boyce-Codd normal form, for example, before a non-key column like professor secretly determines part of the primary key, causing repetitive data. After the messy dependency is moved into a lookup table, a different table. For example, you can see that the professor might determine part. If this professor was placed here, then that's not fine because professor determines the subject. So it's always like this, that it goes on the left, the arrow goes on the left, the professor determines the subject, and that makes no sense because in our situation, just like we mentioned, that a non-key attribute pointing to another non-key, this is third normal form, which doesn't allow. But Boyce-Codd normal form is stricter. It doesn't care about the column. It only looks at the starting point, professor. Because professor is not a candidate key, BCNF flags that violation and wants to split the table. So BCN only looks at functional dependencies. A goes to B, where one column clearly points to exactly one value in another column. BCNF completely binds multi-value dependency, where one column points to a set of independent value. So we have composite keys. Because every single column is part of primary key, there are no non-key columns at all. You don't have any non-key columns. So BCNF stops regular column from being dependent on each other, where fourth normal form stops independent multi-valued lists from being smashed together into the same table. So we can look at BCNF, for example, only stops regular columns from being dependent on each other. And we also know that if two tables had, so there are two tables, one only had keys in it, only keys, and the second table had, the first table might be students. So first table, second table. So first table only has primary key, foreign key, and as a composite key, another primary key or something, or maybe another foreign key. So two foreign keys and together, but this is also in Boyce-Codd normal form because there is no attribute depending on a primary key, or multiple primary keys in one table, and multiple primary keys or multiple keys in one table with an attribute. That's not allowed in Boyce-Codd normal form. But you must separate non-key attributes with a single key, meaning that if two tables had one key and one table only had keys in it and nothing else, and the other had only exactly one primary key and a single non-key attribute, this is also in Boyce-Codd normal form. So if you decompose a problematic table and end up with those two specific structure, it perfectly satisfies the Boyce-Codd normal form. The all key table, if a table contains only keys like composite, primary, made of two columns, there's no non-key attribute at all because there is no regular mixture of anything. It cannot violate Boyce-Codd normal form. Since the single non-key attribute in the table, for example, primary key, for example, user ID, we have, and we have an attribute like age, this was totally fine because there is one attribute, exactly one attribute that goes to something like this. Then we have the only possible decomposition is primary goes to non-key attribute. Since the starting point of dependency is officially primary key, it perfectly follows the Boyce-Codd normal form rule. We have completely mastered the mechanics of Boyce-Codd normal form and how to spot the violation in the normalized table. You see that this is also in Boyce-Codd normal form. For example, what happens if we can see scenario A, composite key is student ID, professor, these both are keys we have, and then we have attribute final grade. We know that this is related to this, like student ID he needs to know the final grade, professor needs to know the final grade. To know a grade, you need to know both specific student and the specific professor who graded them. So there is a dependency in a real world. This is about the real world. And why this is in BCNF? Because the starting point of dependency is student and professor, which is a complete candidate key. The rule is perfectly satisfied. But here it is a violation. Imagine instead we add a column for professor office. So student ID and professor together, and then we add another attribute in the same table saying professor office. So professor goes to professor office. This makes sense, but this has nothing to do with student ID. and an office belongs strictly to the professor, a student ID has nothing to do with where a professor office is. Therefore, the dependency is something like this, not like this. So this needs to be in a single table. The starting point is just professor, but professor is only a part of the primary key, not full candidate key on its own, because a partial key is determining a regular variable. Data will start repeating. Every time Dr. Smith is paired with a student, his office number will be duplicated. Then what happens is that we look at common sense. So it's more about unrelated attributes in real world that violate it, not the form, but what's common sense. So the math, the symbols is just the definition, is just a formal way to describe what is already intuitively know about the real world. For Boyce-Codd normal form has a common sense, and office belongs to a professor, not to student subject pair. So it makes no sense to say, okay, we should put them in one table. Shoving the student table creates a messy hierarchy violation. The fourth normal sense, we can bring it into fourth normal form by saying an employee hobbies and their work projects have absolutely nothing to do with each other. Shoving them into the same room creates a messy explosion. So we know that there's a key and a non-key attribute. If this non-key attribute has something to do with this in the real world, only then we include it in the same one. This is Boyce-Codd normal form. Otherwise, if this has nothing to do with this, then we make a separate table for those that have something to do with each other. And if they have nothing to do with each other, then we just give the key of what it's related to with what we're talking about in the new table. And then it's Boyce-Codd normal form. But in fourth normal form, we already discussed how to convert it.